Hello everyone, welcome to my YouTube channel Self Study. Today we will continue the second part of this chapter number 8, electricity. So this is the second part, that is static electricity. So static electricity, the electricity which we use in our daily life for various purposes such as to glow a bulb, run a fan, etc. is due to the motions of charge. It is called current electricity. Now we shall consider the electricity at rest or at static electricity. The word electricity means from a Greek word electron, which means amber. About 2500 years ago, a Greek philosopher Thales found that when amber was rubbed with wool, it acquired the property of attracting a small piece of paper or cork. Later on, Dr. Gilbert found that beside amber, there are many other substances such as glass, plastic, nylon, hard rubber, sealing wax, ebonite, etc., which also show the same attractive property. The substance which acquired the attractive property is said to be the electrified or charged. When an object made for a substance like glass, plastic, ebonite, amber, nylon, hard rubber, etc., is rubbed with wool, fur, or silk, it acquires an electric charge due to frictions. The object is said to be charged and it acquires the property to attract a small piece of paper, leaves, or cork. This can be demonstrated by the following activity. Activity number 3 and 4, I will discuss it later. Activity number 5 also and activity number 6 also, I will discuss it later. So continue the chapter. The above attractive so that an object can be charged by rubbing. This is a static charge, so the charge can be obtained by rubbing only. If a glass rod is rubbed with silk, means if the activity number 5 is also same here, means if glass rod is rubbed with silk, it will attract a small bit of paper. Similarly, if an ebonite rod is rubbed with fur, it will also attract a small bit of paper. However, a charged object not only attract a small bit of paper, but it can also attract or repel other charged object. It is found that two charged objects having like charge repel each other, while two charged objects having unlike charge always attract each other. Kind of electric charge. Like charge repel and unlike charge attract. There are two kinds of electric charge. We call them positive and negative charge. The existence of this electric charge can be demonstrated by the following experiment. So in this experiment, number 1, take a glass rod A, rub it with a silk to make it charge. Okay, suspend the charge rod A with a thread. Then take another glass rod B, rub it with the silk and bring it near one end of the suspended rod A as shown in figure 8.21. You will observe that the suspended glass rod A get repelled, means this is also a charge rod and B is also a charge rod, so they will repel each other. And now second, take a ebonite rod A and rub it with a fur to make it charge. Suspend the charge rod A with a thread. Now take another ebonite rod B, rub it with another fur and bring it near one end of the suspended rod A as shown in figure 8.21. You will observe that the suspended ebonite rod B A get repelled. This is also get repelled because both are charged. Now in 3, now suspend the glass rod A rubbed with silk by means of a thread and bring the ebonite rod B rubbed with fur. Now both the rod rubbed with another material like glass rod rubbed with silk and this one B ebonite rod rubbed with fur. You will observe that the suspended charge rod glass rod A get attracted toward a charged ebonite rod B. In all the above steps, if the rod have not been rubbed with silk or fur, we would have found that there is no repulsions or attractions between the rod. Thus, the attractions and repulsions between the rod arise only when there are charge. In step 1, both the glass rod have been rubbed with silk. They must have similar kind of charge. It is seen that this rod, when brought near each other, repel each other. Hence, it is concluded that like charge repel each other. Similarly, in the case in step 2, now in step 3, it is seen that the glass rod rubbed with silk attract the ebonite rod rubbed with fur when brought near each other. Therefore, it is concluded that the charge on the glass rod rubbed with silk must be opposite to the charge on the ebonite rod rubbed with the fur. This experiment suggests that like charge repel while unlike charge attract each other. Thus, from this experiment, we can conclude that there are two kinds of charge. Like charge repel and unlike charge attract each other. When other substances are charged by rubbing and are tested in a similar manner, it is found that they fall into the following two categories. Number 1, substances which have the similar charge as they developed on a glass rod when it is rubbed with silk. They are said to have positive charge, or they are said to be a positive charge. Point number 2, substances which have the similar charge as they develop on the ebonite rod when it is rubbed with fur are said to have negative charge, or they are said to be a negatively charged. Thus, there are two kinds of charge, a positive and a negative charge. Conservations of charge. Before rubbing the two objects, each object is uncharged, so the net charge is 0. Now, when two objects are rubbed together, both are charged equally, but the charge on them are of the opposite kind. Thus, the total charge on the object before and after rubbing remains same. This is called the conservations of charge. When a glass rod is rubbed with silk, the glass rod is charged positively and the silk is charged negatively by the same amount. Similarly, when an ebonite rod is rubbed with fur, the ebonite rod is charged negatively and the fur is charged positively by the same amount. Explanations of charging on rubbing. Each body has atom. An atom is electrically neutral. It has proton and neutron inside its nucleus at the center, around which the electron revolves in different orbit. The number of electrons in an atom is equal to the number of protons. Means the number of electrons in an atom is equal to the number of protons. However, some of these electrons can easily leave their atoms. These are called free electrons. What are called free electrons means the electrons which can easily leave their atoms are called free electrons. The two objects which are rubbed together are initially neutral. When they are rubbed together, the free electrons are transferred from one object to the other. The object which gains free electrons become negatively charged, while the object which loses free electrons become positively charged. Means the object which gain free electrons become negative charge, and which lose electrons, free electrons, become positively charged. Example number 1, when a glass rod is rubbed with silk, the free electrons from the glass rod are transferred to the silk. The glass rod loses some electrons, so it becomes positively charged, and the silk gains the same number of electrons, so it becomes negatively charged by the equal amount. The charging of glass rod and silk on rubbing is shown in figure 8.24. Means before rubbing, both are glass rod and silk are electrically neutral. And B, while rubbing the glass rod with silk, electrons are transferred from glass rod to the silk. And now, after rubbing, the glass rod become positive charge and silk become negative charge. Point number 2, when an ebonite rod is rubbed with fur, the free electrons from the fur are transferred to the ebonite rod. The fur loses some electrons and it becomes positively charged, and the ebonite rod gains the same number of electrons and it becomes negatively charged by the same amount. The charge of ebonite rod and fur on rubbing is shown in figure 8.25. Means charge of ebonite rod and fur of rubbing. Before rubbing, both the ebonite rod and the fur are neutral. While rubbing the ebonite rod with fur, electrons are transferred from fur to the ebonite rod. After rubbing, the ebonite rod becomes negatively charged and the fur becomes positively charged. Now, Conductor and insulator. In class 7, you have learned that substances such as silver, copper, aluminum, iron, brass, steel, mercury, carbon, human body, etc. are conductor of electricity. They allow electricity to flow through them. But substances such as cartoon, rubber, plastic, wood, paper, glass, ebonite, mica, wax, wool, pure water, etc. are insulators of electricity. They do not allow electricity to flow through them. The reasons for some substance to be conductor and other is to be insulator of electricity is that different substances have different number of free electrons in them. So substances which have a large number of free electrons are called conductor. And substances which have large number of free electrons are called conductor, while those with very less number of free electrons or no free electrons are called insulators. The conductor allows charge to flow through the motions of free electrons, but the insulator do not allow the charge to flow because free electrons are not available for motions. Only insulator can be charged by rubbing. The conductors cannot be charged by rubbing because charge developed on them will flow away and will not remain with them. Method of charging a conductor. You have learned that the two insulators can be charged by rubbing them together. But a conductor cannot be charged by rubbing it with another conductor. A conductor can be charged by the following two methods. How conductor can be charged? By conductions and by inductions. First, charging a conductor by conductions. In this method, a conductor to be charged is touched with the charged body. The conductor gets charged by the similar kind of charge as the charging body. The charge of the charging body is shared by the conductor to be charged. Suppose we went to charge a metal rod A with positive charge. Place it on a insulating stand. Take a positively charged glass rod B provided with the insulating handle and touch it with a metal rod A, as shown in figure 8.26a. Some positive charge. Insulating hand, insulating stand, metal rod, both have positive charge. Charge of a glass rod B is shared by the metal rod A. Remove the glass rod B, the rod A get positively charged. Now remove the glass rod B, so the rod A already get positively charged. Explanation: the glass rod B is positively charged, so it has a deficiency of electron. When it is touched with the metal rod A, the free electrons of the rod A move to the glass rod B. Due to loss of electrons in the rod A, it becomes positively charged. It may be noted here that the insulator cannot be charged by conductions because it does not contain free electron, and so it does not allow free electron from the charged body to flow toward itself. Note: to charge the metal rod A negatively, an ebonite rod B rubbed on fur is touched with the rod A. Point number 2. Charging a conductor by inductions. In this method, the conductor to be charged is not touched with the charged body, but it is kept near the charged body. The end of the conductor nearer to the charged body acquires a charge opposite to the charge of the charged body, while the other end far from the charged body acquires a similar charge as that of the charged body. Suppose we went to charge a metal rod A negatively. Proceed as follows. Number 1. Place rod A on insulating stand. Take a positively charged glass rod B, provide with an insulating handle, and bring it near the rod A as shown in figure 8.27. This is figure 8.27a. The near end P of the metal rod A acquire negatively charge, while the far end Q acquire positively charge. On removing the glass rod B, the metal rod A become uncharged as shown in figure 8.27. This become uncharged. Explanation: the positively charged glass rod B attract the free electrons of the metal rod A. Therefore, the free electrons of the rod A move from the end Q toward the end P. Thus, the end P become negatively charged as it gains the electrons, and the end Q become positively charged as it loses the electrons. On removing the glass rod B, the electrons of metal rod A move from the end P to end Q to neutralize the positively charged. Number 2. Now touch the end Q of the rod A by hand and then remove your hand as well. as glass rod B simultaneously as shown in figure 8.28a. 8.28a charge by inductions, and B, the glass rod A become negatively charged. Explanations: on touching the end Q of rod A, the free electrons move from earth to neutralize the positive charge at the end Q. On removal of glass rod B and hand simultaneously, the negatively charged at the end P get distributed throughout the rod A, making it negatively charged. Note: to charge the rod A positively, a ebonite rod B rubbed on fur is to be used. Now the difference between conductions and inductions. In conduction, the charged body is touched with the uncharged body. Point number 2, the charge is shared, so the amount of charge in the charged body reduces. Point number 3, the charge on uncharged body is of the same types as that of the charged body. Point number 4, on removing the charged body, the uncharged body still retain the charge. Now inductions. Point number 1, the charged body is not actually touched with the uncharged body, but it is only kept close to it. Point number 2, the charge is not shared, so the amount of charge of charged body does not decrease. Point number 3, the charge on uncharged body is of opposite type to that of the charged body. Point number 4, the charge on uncharged body remain only as long as the charged body is closed. As soon as the charged body is removed, no charge is left on the uncharged body. To retain charge, the far end of the body has to be unearthed. So thank you for today. Please subscribe to my channel for the next part. Thank you.